So we're going to open here to the page with the 2016 FRQ. We're not going to do that multiple choice. It's in your packet or your homework for today. So we'll just go through it together. Whenever I do these in class, I pick weird ones. Usually what happens then is when they get on an exam, they're just kind of the normal medium ones. In 2016, they had one that threw them for a loop, and I kind of want you to just read what this stuff represents, and then we'll talk about it. All right? So just go ahead and read the problem. Make sure you know what that graph is. When you're done reading the stem of the problem, I want to make sure you've kind of absorbed some stuff. What level are you on for this expression right here? Position, velocity, or acceleration? This is velocity. What is the graph of? Position of y. How would you get the velocity at any time? Slopes. So you got to kind of think about that. They'd never, in this year, they came back going kind of, what was up with the graph? And it's actually easier because when it says what's the position at t equals 3, well, the y position's right here at -1/2. You might say, how do I know that's exactly at 1/2? Because it's going up 1 over 2. You know what I mean? So it's 1/2 is what the slope is. So that it almost makes it easier, but kids were trying to do the long way to get position, which you need to for the x coordinate. So I'm not going to write it down. You guys go write it down. But you would put parentheses or chevrons. It doesn't really matter. To get the position of the x, you will need to integrate. So then you would say to yourself, well, okay, that's why they gave me a starting position, right? So what would you write down for your x coordinate? Just an expression for it before you go to your calculator. Go ahead, Lainey. I have the velocity, and I want the position. I'm going to need to integrate, correct? And where am I going to start before I even integrate? Where is this sucker? 5, Peyton. Yeah, so in parentheses, you're going to write 5 plus the integral from, it's not always 0, but this one's 0, right? 0 to what? 3 of t squared plus, or you can write x prime of t. Actually, this one just says, this is calculator active. So you can go ahead and put 5 plus the integral from 0 to 3 x prime of t dt, and you can go to your calculator and enter that. So we'll get the x coordinate. Just make sure you enter it correctly, but you can just be in your regular old mode. You don't need to be in parametric mode, and you can just do 5 plus, it doesn't matter if you're in parametric. The only difference is when you hit this button, it'll put a t instead of a x. So 5 plus math 9, and then it was from 0 up to 3, right guys? And I'm not going to type it in. Then you type that stuff in, and then dx. I don't want to type it in, but you guys can tell me what you get for that x coordinate. And if you guys work your calculator fast enough on that, I shouldn't need to, right? What did you get when you entered it? Do I have a backer on 14.377? Okay, and comma. And then what's the y position? What's the y position? Just wherever you are on the y graph, because it's giving you the graph of y, correct? So that would be -1/2. So you would just say that, the 14 whatever, comma 1/2. The next it says find the slope of the tangent line. That's dy dx. So what do you need to do on the top of your fraction? Because we need to do dy dt over dx dt. How are you going to get dy dt? The slope here. Yeah. So it'd be up 1 over 2. So you're going to have 1/2 over. How are you going to get dx dt? Pretty easy, right? If you understand the questions, parametric isn't too bad. But to get dx dt, you can just go plug it in. 9 plus sine of 3 times 3 squared. I don't know what that is. And you can just leave it as a fraction. Once it's all numerical, you can go ahead and leave it. So 1/2 over, and just because we should all be entering on our calculator. The point of today is kind of the calculator work. So I do want you all entering. So on the top would just be the slope, 1/2. On the bottom, 3 just goes in to dx dt. Make sure you're in radian mode. And what do we get on the bottom of the fraction? Do you have it, Felicia? Do we have a 9.956? If you're not getting that, ask me for help on the calculator later, because it's really important you know how to work your calculator for these. And you can just leave it as a 1/2 over or 0.5 over. Are we good with that? Because I didn't hear a whole lot of consensus on that one. Yep. All right. The next one says, find the speed. Okay. To get the speed, you already have part of it on your calculator, correct? Maybe store that last answer. Because don't you have to do the square root of dx dt squared plus, correct? And didn't we just find dx dt squared at 3? So when you only have a certain amount of time for your FRQs, I would take whatever Felicia just told me, 9 point blah, 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 right? Is it sitting right on your screen? Hit store, and then maybe put it in something like A or whatever. But to find the speed, you should write down the square root of dx dt squared plus dy dt squared. You should write that down, showing your AP reader that you know the model, so you get 1 point for that. And then you're going to go to your calculator and you're actually going to do it. I would suggest you store what you got for this so that you don't have to type it in again. But if you want to, it'd be the square root of parentheses 9 plus sine 3 times 3 squared, close it, square it. It's going to be messy. So I'd store as much as possible in parametric. And then plus dy dt squared. I'm going to write that up there. I'm not working my calculator yet. I'm purposely staying off it. On the next one, I'm going to bring I have it in the background. So your speed, you're going to say it's the square root of dx dt squared plus dy dt squared, which is the square root of, and our dy dt was a 1/2 squared, so you can even just do a 1/4. And remember, when we're not on our calculator, to 3 decimal places, and to square your dx dt squared at t equals 3, whatever you got for 9 plus sine of, what would it be, 27, right? Anyone want to give me an answer who's typed the whole thing in? You're usually pretty fast on your calculator. What do you got? 9.969? Yep. Okay, I saw a lot of head nods. 9.969. Perfect. Next it says find the total distance traveled. They could have said also to find the arc length, correct? But total distance traveled, we integrate from 0 to 2. Our speed, so the square root of dx dt squared. Now, if you put this in y1, it'd be really nice to be able to bring that in. You know what I mean? So that's kind of up to you, but you have to do your dx dt quantitatively squared plus your dy dt. And then I want you to notice what should happen if you tried to do that. That should trigger something for you. Because think about what dy dt is. What is dy dt again? The slope, right? And what's the problem from 0 to 2 when you're like, what's the slope? There's 2 different ones. So what do we always do when there's 2 different things when we're integrating? Split it up. You're going to have to go from 0 to 1. Square root of your dx dt squared plus, and on that one, your dy dt squared is 2, or negative 2. You're going to have to, again, type that in. We're not typing it in right now, but otherwise if I do it, sometimes you guys don't, you just watch. And then you're going to have to go from 1 to 2, the same thing, square root of, but then the slope is 0. I'm going to see what the answer ought to be for that one. Do you think many kids across the world thought to split that one up? Now, I've never read for BC, so I didn't grade any of these, but my guess is very few kids 9'd this one. It was just weird. All right, I'm going to bring up the scoring rubric to show you how it was scored, and then we have one more. That was the weirdest one I could find, so if you were fine with it. 2000. Typing fast here. And again, if you're not getting any of that stuff on your calculator, ask me separately. So, letter A was worth 3, 1 for setting up the integral for the x, 1 for knowing to use the initial condition, so just writing 5 plus, and then 1 for the answer. And we had that answer correct, right? You guys told me 14.377. All right, and the next one, we needed to do 0.5 over 9.956, whatever. Okay, and you could just leave that numerically. Our speed, it's exactly what you guys told me. They allow you to truncate or round. Do you know what truncate means? Did we talk about that last year? Either cut it off at 3 decimal places or round it, so they take the 2. So on this one, you were supposed to split it up into 2, and they got a 4.350 or 4.349. Did you guys get it to work? If not, I want you to write that answer down, and I want you to, when you're in your groups, have somebody help. It's hard because I have different calculators in here, and I'm a little worried about Annika. How is your calculator? I remember last year when we hit parametric, that calculator was not user-friendly. Are you able to do it?
What?
Are you able to? Yeah.
Well, this is fine.
This is fine? Okay. I'm just making sure. I just remember there are issues in parametric. Okay. And you shouldn't need to. So that's good. But all this worked out? You were able to find all your commands?
Yeah, I think so.
Okay. All right. So if you could, how many of you got that on your calculator? Not many. Oh, you did? And you're not raising your hand? You're still typing. Okay, it's just... Oh, yeah, that's huge. You'd only lose the answer point, though, as long as you set it up. If you can't work your calculator correctly, you only lose 1 point. But I'm going to try on the next one to show you some quicker ways to use your calculator. So we'll go back to that if you need to, or when you're in your group, if you have somebody with the same calculator you do. I unfortunately have to use the one they give me for free. All right, so our next one is going to be this guy. It's an old one, but it does say it was calculator active. And again, I try to find them when they're weird. So the first part says to find the position when they're given the position. So that's just a plug and chug. So let's just go to A, and we're supposed to just do the position, which would be 3 cosine of 5 halves pi when t is 5 over 2. And then we'd have to do 5 sine of 5 halves over 2 pi. All right? So it's just a position. You can't leave trig functions because that's not numerical. So you need to know where 5 halves pi is. So make sure you're 100. When you go around the circle, you're at 0, right? Then you're at 2 pi, then 4 pi, right? So 5 pi over 2 would be the same as pi over 2. Or divide it by 2 because then you get a half left. But that's actually going to equal 3 cosine of pi over 2, 5 sine of 5 over 2. You end up doing a full circle and then another pi over 2. Or 2 and a half pi's. Does that make sense? Sometimes like in AB we had a 7 pi over 2 the other day and they didn't know where to go for that one. So I'm just making sure. So the correct answer would be at 3, right? No, 0, comma, 5. Easy question. They gave me position. They ask about position. It says on the axis provided, sketch a graph. This is, it does say though this was calculator active, right? But in 1997 they didn't have these kind of calculators. So we're going to kind of change the problem a little bit. I want you to know how to do it both ways. So if it's calculator active and you have to graph it, go do it. What button are you going to hit? Plus, I want you to have them in. So go ahead and hit your parametric mode. Go enter 3 cosine pi t, 5 sine pi t. And I'm going to bring up my calculator for this one because I'm going to do this one as if you had a scientific calculator for the whole thing because it's got some good entry on it. So we are going to hit our, and I'm talking guys because of the video. We are going to hit our parametric mode. Those of you at home. We are going to Go to y equals. I'm going to clear off my old stuff. Now keep in mind, anytime you want to use it, it's already typed in. So we're going to be doing some var stuff with this too. So 3 cosine Annika, you went, I don't know about you for this one. All right. Make sure you hit window next, because you need to kind of create what you need to. It says to go from 0 to 6. Okay. T-step of 0.05, 0.01, I kind of like a little better. I like to, a little. My x min, think about that. What's the lowest x will ever be if it's 3 cosine? You want to get a nice graph. What's the lowest 3 times cosine of any angle could possibly be? -3. Yep. Cosine's lowest is a negative. The most it can be is a 3. For 5 sine, the least it can be is -5. The most it can be is 5. Oops, sorry. Have the x scale by 3 by 1s. And then let's go -5 to 5. Sorry. It's awkward using my... All right. When you hit graph, you're going to see it traced out. It does say, though, to provide the direction of the particle. So make sure when you look at your calculator graphing it, you see where it starts. Or if you're not sure, plug a 0 in for t, and you're going to see that it starts at 3, 0. Either way, go ahead and hit graph, and it'll, if you wanted to slow that up, it's still going, by the way. It's not quite done yet. But there's your graph. Go ahead and sketch it. And I would zoom, square it up. Again, I purposely chose very calculator heavy ones today. That's actually what it should look like. So I'm going to go sketch that out. Yep. You need to, that is what mine looks like. Okay. Yep. I had to zoom square mine. It came out really funky. But it goes up here and around. Oops, sorry. Up and around. I'm trying to draw it. And then it says to show direction. So it started at 3. And it, again, if you couldn't see that on your calculator, just plug a 0 in for t and do it in your head. Then it says how many times. So part B is done. Part C, it says how many times does a particle pass through the point in part A? Well, when you go around here, you kind of got to think about, you could trace it on your calculator if you want to, but the first time that it's going to get up here is when t is a half, because then it'd be 3 cosine pi over 2, 5 sine pi over 2, correct? So when t is a half is the first time it's going to pass through there, but we're doing it to 6. So it'll pass through there 3 times. Does that make sense? Or you could even just hop on your, go hit trace, and if you want to just walk around until t gets to 6 and count every time it gets to the top. But t would have to be a half the first time it gets up here, because we'd be doing cosine of pi halves 0, 3, and then sine of pi halves, which would be 5. Or you could just hop on and trace. By the way, when you trace in parametric, I believe you have to use the right arrow button to get t to go forward. So it's awkward, because even if you're moving to the left, you're moving t forward. Am I correct? Because I haven't graphed in parametric for a year, but I remember, yeah, I suppose I can try it up here. Yeah, it's not going to work. All right, so then for part D, this is kind of the one I wanted you to be on your calculator for. It says, actually it's part E. Find the velocity vector for the particle at any time t. So what that means is an expression. So our velocity vector at any time t is going to be equal to, that means you need to take the derivative by hand. Okay? So it would be -3 sine pi t times what? Times pi. Yep, so that's a nice easy one. The other one would be 5 cosine pi t times pi. Done. That's pretty easy, right? Just take the derivative by hand. Now, it's kind of part E why I scrounged for this one, because I want to show you what your calculator can do if you're good at working your calculator. All right. So if you already in your y1 and y2 have this in here, your calculator can do the dx dt and the dy dt under the root inside of the integral. So you just have to know what to push. If it bugs you, you'll just do it all by kind of like type a bunch of stuff in. But if you do, it says find and evaluate the integral expression that gives the distance the particle travels. So I'm going to go second, quit, and I'm going to talk about how we get distance. Okay? The distance traveled is an integral, correct? I'm just going to hit math, and I'm going to hit 9. And then it says from 0 to, I can't read it. No, it doesn't. What does it say, you guys? Can you tell me? 1.25. I'm going to make my calculator do the whole thing. I would then also tell my AP reader what my setup was. All right? And you said to 1.75? So follow me with your calculators. Hopefully I remember. Sometimes I forget these entries. But the first thing you'd have is a root. Okay? What do you do under the root for total distance traveled? Yes, you need to square dx dt. Your calculator can do that. You already have your positions loaded in your graphing utility, correct? So if you were to put parentheses down, because he said you're going to have to square it, so we do need parentheses, we can math 8 under that root in parametric mode. Okay? Notice a t popped up. Doesn't matter. I'm in parametric mode. What function do I want to take the derivative of? The one that's I already typed in. What button do I hit to draw that up? Vars. And if you move over, you'll see there's a parametric option under vars. See what I mean? So your calculator can be used. It's just it's so complicated you might forget it. And if so, I'll show you that. So we want to put x1 in there. This is the trick. It has to run through all t values from 1.25 to 1.75, so I don't put a number in there. What do you think I'd put in there? Another t. Yeah, we did that last year once where we went from x to x. All right? Now I need to close that, so I need to move over. I need to close it, and I need to square it. That's pretty complicated, but if you enter it right, you're not going to have a calculator error. Does that make sense? So your calculator is going to take care of everything. So you guys go try doing plus the dy dt quantity squared without looking up here. And remember, if you're going to square it like Cadence, you need those parentheses first and squaring last. It's kind of satisfying, but it's hard to remember sometimes. I feel like I entered too many parentheses on mine even because I wasn't paying attention. Let's hope not. I might have. Did you guys get an answer? And a dt and an extra t. I know it's kind of boring, but it's important you know how to work your calculators. I'm going to hit enter. I think I had too many parentheses, but maybe not. You guys get the same thing? Now, if you just write that down, you're going to get 0 out of 2 points. So make sure you write down the formula down. So you're going to integrate from 1.25 to 1.75 the square root of x prime of t squared plus y prime of t squared dt, and then go to your calculator and do it. Did you get it to go? All of you did? All right. So why did I do those? Calculator. And I'm going to give you for your homework, it's that more calculator than normal. I might have you skip some of the ones I know you know how to do, too, just because some of it's repetitive. Although it is kind of satisfying to do these, so I forget. Like the first one's real easy, but you'll be like, oh, sweet, I know how to do that. It's satisfying to me. I do want to find a calculator active one here first, just to make sure our calculator's getting worked correctly. Let's go do. Go do number 6. It's actually, there's so much workspace. It's not that long. And the multiple choice was really fast. I did the key in like 10 minutes. Yeah, it won't take all of it. It shouldn't. Most of it's review. You might pause on some of the calculator entries, but you should be able, honestly, to get half of it done in this year. Go try number 6 though. Your options are to take the derivatives by hand and then go to your calculator, or make your calculator take the derivatives. What do you think I'd suggest on number 6? I actually wouldn't, because I don't need to graph it, and they're easy derivatives. But I could. If it's part in an FRQ though, and you've already graphed it, and it's more complicated, like a number 10, so I want you all to do number 6 first. I want you to know when and how to use your calculator to your best benefit, and on that one, I would just do the derivatives in my head. Plug the 2 in my head. Yep, and then you have to take the square root of that squared plus that. It says the speed. Speed is the square root of the FCT squared plus CY. Did you do it all in your calculator? Huh? I don't even know, so that's not it. Can we get an agreement on number 6, whether you did it, made your calculator do it, or whether you took the derivative yourself? What do we get? 12.3 what? 04, do you agree, Hannah? You agree? Okay, 12.304. If you didn't get that, you're going to ask me in a little bit after you all go look at number 10. Now when it's an FRQ and they're more complicated, what am I going to suggest you do with both of those expressions? I would go put them in to your calculator, even though you don't have to graph it, you don't have to see the graph. I would type them once neatly into x1 of t, y1 of t in your parametric mode. And then anytime you need, even if you need acceleration, then you can just map 8 those. And so when it's an FRQ and they're complicated, lock them and load them in x1, y1. And then do all of number 10. And I'll put the key to that one up in about 5 minutes. Ten is typical. That's usually how the FRQs flow. Very predictable questions. I posted the key too, but I'll bring that one up so you don't have to log into your Chromies. Whoops, I forgot to pause.